Hey friends, with how almost every JavaScript framework today is implementing signals, I thought it would be really interesting to actually learn how signals work under the hood, why is every framework adopting them, and to understand that we're going to go briefly through the history of reactivity in JavaScript, and then we're going to implement signals from scratch to understand how they work. To understand signals, we need to understand the current limitations of reactivity in JavaScript. So for example, I can define a count value and set it to 0, and let's say for example that we want a double value. You can say count times 2, and this is really cool. But now, for example, let's say that we reassign count 10 and we want to console log double. Of course, double is going to be 0 because it's going to evaluate only once here, right? So now when we open our terminal and now we can run this, you're going to see this is 0. Alright, so maybe thinking, okay, we can turn this into a function, for example. So now this is going to give us a fresh value each time. So now we can say double, and this should be 20 now. And this works great, but let's say for example that we want to do certain things when count updates. So in essence, we want to subscribe to it. We want to do this because this is really tedious. For example, now if we change count to 20, again, nothing is going to happen if we run this because nothing is reactive, right? So we always have to do this tedious work. Now this is going to output 20 and 40. And to solve this problem, people came up with the observer pattern. So if we go here to the observer, we can read the definition of the observer. Observer is a behavioral design pattern that lets you define a subscription mechanism to notify multiple objects about any events that happen to the object they're observing. As you can see in this example, this is the observable or the subject, and these are the observers. And in this example, they're using mostly classes, so we're going to see a bunch of different examples of this, and there's a lot of variations on the observer pattern. But basically, you just have these objects or functions that can subscribe to the observable. In this example, they talk about an object or class which has a .update method on it. But this doesn't have to be an object at all. You can just pass a regular function. And we're actually going to first implement the observer pattern to understand the differences between it and signals. Even though signals are based on the observer pattern, but they're not the same. And also, if you want to read the observer pattern using JavaScript, here you can see this code example. And here is actually a pretty cool demo, so you can see how we can use the observer pattern. So when we handle a click or handle a toggle, we actually want to log something and we want to pop a toast. So you can see in this example how we're going to notify it, and it's going to run the log and the toast. And signals aren't even a new thing. In 2010, there was this JavaScript framework Knockout which used signals. So for example, if you go here to the tutorial, we're going to actually see something really familiar. Let's go to step 2, and now we can see introducing observables. So this framework already had a lot of the concepts about binding values, using observables, and etc. So let's actually just solve this. And now we're going to see when we update to something and go to next one is going to update live. So how beautiful is this, friends? And even if we go to the next step, we're going to see there's also other things here like computed and etc. If I zoom in, we have observables and we have computed values. So using this system, you don't actually have to worry about the plumbing in your code. You can just set these relationships and they're going to update because they depend on each other. And Knockout, of course, inspired frameworks like Solid. So you can read this post by Ryan Carniato, the CEO of Signals. He didn't invent signals, but he made them popular. This is a really awesome post that explains fine-grained reactivity. It just means it's going to update only what's required. So fine-grained reactivity is built from a network of primitives. And in this case, the primitive he's talking about is signals. So we actually have this proposal here, which is really awesome. So if they become part of the language, the JavaScript engine can optimize for them and etc. You can see here is even a polyfill that you can try out today. And they have some awesome examples here, for example, how you can use them with decorators and classes. So you can also remove a lot of boilerplates. So for example, here we have expert class counter, and then we can use decorators like this to make writing our code easier. And there is this another awesome post from Ryan Carniato, building a reactive library from scratch. This is what I'm going to base the signals example. I took this as an inspiration and I made it also a lot simpler because we don't need things like nested reactivity. But I'm going to post all of these links in the description if you want to learn more. Alright, so let's implement the observer pattern. So here I have just a simple counter example, nothing special. As you can see, if I inspect it, this is just a regular button set to 0. And that's basically it. Alright, so how can we implement the observer pattern? And it's actually surprisingly simple. So in this case here we can have this observable, which can be a class or a function. It really doesn't matter. It can hold a value, some logic. It's really not important. It has subscribers, a subscribe, unsubscribe, and update method. We're actually going to see we don't need an unsubscribe method. And then we have these subscribers. So these are the observers, and then when this observable updates, we can update our count, for example, count.increment, and then we can fire off an update so we can notify our subscribers. And this can be anything, right? So for example, this doesn't have to be an object. This can be just a regular function. We can, for example, invoke count.subscribe, and then we get the freshest count value, and then we can update this value inside the button. Or if we want, we can have another subscription. We can say count subscribe, then we get the freshest count value, and then we can just log the value out. So this is using a one-to-many relationship, and the observer pattern is event-driven, and you're also going to hear a lot about this push and pull system, but in this case, this is a push system because we're just pushing an update, and then we do something based on that. So the observer pattern uses a push mechanism. And one thing worth mentioning is that you're constantly using the observer pattern. So for example, let's look at this example. You might have heard of the publish subscribe pattern, and this has different names. No one can agree on this, right? So there's the mediator pattern, publish subscribe. This is the observer pattern, right? So for example, here we have this button, add event listener, which looks really familiar. So we subscribe to the click event, and then we run some action, right? And that's basically using the observer pattern. So in my code example here, I'm just going to query this button in my example, and then I'm going to log click. So when I open the developer tools, and this is going to just log click. That's basically it, nothing fancy. And as I said, this is really kind of annoying. So for example, here we have count here, and now we want to update the value of this button. We can say button inner text, and then we can say ++ to increment the count. And this should work, but again, it's really annoying. And what if different parts of our app want to subscribe to this value, right? So this is where the observer pattern comes in, and it's very simple to implement if you remember what we need to pass in. So for example, here we can create a class or a function. We need subscribers, the subscribe method, and an update method. So let's implement that. I'm going to go here and I'm going to create a function observable. Now what do we need? Subscribers. And then instead of using an array, I only want unique subscribers, so I'm going to use a set. And we can just say new set, that's it. And remember, we just need to return two methods. So we need subscribe, this is going to take a function, and then we also need an update method, which is going to take the new value. And now anyone can subscribe to this observable, and this doesn't have to be named observable. This can be named banana, count, whatever you want. And now we can go here and add this to our subscribers. So I'm going to say subscribers, add, and I'm going to add this function. And again, this is just a simple function. We're not passing an object or anything else. And the reason I haven't included an unsubscribe function because I think it's really easier to just return a cleanup function. So you can just say return, and we're just going to return a regular function. So we're going to say subscribers, remove the function, right? So we don't have to pass it as a reference or anything else. It's just going to get removed. And then to notify the subscribers, and again, this can be named anything you want. You're going to see different names for this, notified and etc. I'm just going to name this update, and then we're just going to loop over the subscribers and execute the function. So I'm going to say subscribers for each function. We're going to execute the function, and we're going to pass the current value. All right, so let's export this observable. So I'm going to say export, and then we can import it here. So we're going to say import observable from observable. That's it. So now we can assign count to be observable, and now we can subscribe to this count and do whatever we want. So for example, we can say count subscribe, and then let's say, for example, that we want to pass in a message. We can say message, and then we can say console log message right here. And then here inside of click, let me just comment this for the time being. Now we can say count update, and then we're going to send this message hi. All right, so now we can save this, and now let's go here, refresh everything. So now we should see hi each time that count gets updated. And as you can see, this works beautifully. So now anyone can subscribe to this count and do whatever they want, but this really isn't that useful. So for example, we can add some logic inside of the observable. For example, we can pass in a value here, and then let's have an increment method here. So inside of here, we're just going to increment the value that we passed, and then we're going to notify the subscribers. So just by saying update value, we have to use this to refer to the method that we're returning, right? So we can say this update, and then you can pass the value. All right, cool. So now actually here we can pass the initial value, which is going to be 0. And now this is the beautiful part. So now we can yoink this, and now we're also going to get the count, right? So now we can just go here, and we can always get the freshest value. Now we're going to subscribe to the count. Each time count increments, we're going to notify the subscribers. And now we can just assign this to count. And inside of here, we no longer have to call update manually because we can just say increment. That's it. So now each time we increment this value, we're going to notify the subscribers that the value has changed and this is going to get updated. And now this is the beautiful part because we no longer have to do things manually. And we can of course add another subscriber. So for example, here we set the inner text, but in this example, we maybe just want to log the value out. So we can say console log count. Okay, increment is not a function. Let's see. So again, let's see, maybe I didn't save. So we can go here, refresh everything, 1, 2, 3, 4, and there you go. I forgot to save. Silly me, right? But we can see everything works great. And remember how we returned the cleanup function. So here is how we can use it. So for example, we can say here const unsubscribe. And now we can just invoke this function here. And this is going to do the cleanup. So this is going to remove the subscriber from the subscribers, right? So it's saying remove is not a function. And that's because I'm silly. It's not remove, it's delete. Cool. Now we can save this. And now you're going to see it's not going to log, but it's going to update the counter because we ran the cleanup on this subscription where we just log the count. Alright, and this is great, but what is the limitation of this compared to something like signals, where we're going to actually see when we implement signals, but for right now you can see that it's really tedious that we have to set these subscriptions up ourselves, right? So for example, let's say that we have some value here, which is double. So now how can we update it? So for example, here where we have this subscribe count, are we just going to do this? We're going to say double, for example, and then we're going to say, okay, double equals count times 2. And then we're going to do something with that, or we can even put double here inside of this observable or whatever. But as you can see, it's starting to get unreliable, right? And it's easy to make mistakes. So what are signals? Signals are also observables, but they're also called atoms, subjects, or refs. Signals are event emitters and they use a hybrid push and pull system. But what makes signals unique to using the observer pattern? In this case, here we have a simple signal which can be a function or a class, and it also has subscribers, but unlike the observer pattern, you use a getter and setter. Whenever you access the value of a signal, then you're going to automatically add a subscription to the signal. And once you run that code in the subscription, you're going to get rid of it. And then when you update the value of a signal, you're going to run all of the subscriptions. And this happens constantly, and unlike the observer pattern here where you just push out an update like this to all of the subscribers, here I purposely draw these arrows here so it looks more like nodes, right? So all of this is connected and this gets rebuilt each time when you access or update a signal. And a signal is just something that holds a value that may or may not change over time. So signals alone are not very interesting without their partner in crime, reactions. So what are reactions? Well, reactions are the derives, effects, computed, or whatever else name you can think of for them. So they observe the signal and rerun each time their value updates. So for example, for the count here, we can have a derived count.value times 2. When we access this value, we're going to create this dependency graph. And same when we're using effects, where we just want to update this inner text value using count value, we're going to update the dependency graph to have this count text value. And this is basically what runtime reactivity means. As your code is running, you click a button, do some action, this entire graph is going to be rebuilt each time. Dependencies are going to be added and removed. And this is the main difference from the observer pattern, because you don't have to think about any of this. Once you set up signals, that's it. They're going to take care of everything else. In the case of having derived values like this, they're also going to get automatically memoized, which means that you're going to save on having to compute the value again, because it's going to get computed once it runs, and then it's only going to get updated if that signal updates. Alright, so let's create a simple signals implementation. I'm going to create a function which I'm going to name signal, and I'm going to pass in a value. So now we need to keep track of the signal subscribers. So I'm going to say const subscriptions, new set, and now we need to return a getter and a setter. And you can do this however you want. You can create a read and write function, return a tuple, or you can just return a JavaScript getter and setter. So I'm going to do that. I'm going to say return get value, and I'm going to say set value. For this, we just need to return the value, that's it. And basically here we're going to receive the updated value, and now we need to update the value to updated. Alright, and that's basically it, but as we read before, this is really useless because a signal is nothing without a reaction. So for example, if we export this signal, and now we can go here, and let me just import it. Import signal from signals, that's it. Cool, so now we can go here and we can say let count signal, and now here we can say count.value. Let's go back to our example, and now we're going to see it log 0. But of course, as I said, this is useless because we need effects and derives to make signals useful. And what do I mean by that? Well, for example, here in this add event listener, let's say, for example, that whenever we update the value of count, so let's say count value plus plus, whenever this happens, we actually want to reactively run some effect or whatever, right? And let me actually just save this. So this is going to increment the value, and then we want some effect here. We can just make something like this, and then we can say console log count.value. And because here we have this signal inside of here, when we read this signal, we're going to add it as a subscriber or a dependency, this effect, and we're going to run it. And this is going to happen every time. And this is why signals are so awesome, because this happens dynamically. Alright, but enough talking. Let me actually show you how this works. So for example, here we have this effect, and let's also say export function effect. We're going to pass in a function. This is really similar to .subscribe, right? And then we're actually going to need a value to track the current running subscriber. You're going to see this named context and whatever. But I'm just going to say let subscriber. I'm going to set this to null. And now we're going to set the subscriber to the function. We want to run the effect immediately. And then when we're done, this is superfluous, but let's just keep it clean, and we're going to set the subscriber to null. Alright, so now what's going to happen, because look at this, inside of this effect, this way signals are so awesome. Because we're saying count.value, we're going to add this function here. We're going to invoke this immediately. So what happens when we invoke this function? We're going to run count.value. And what happens when we read the value? Well, right now it happens nothing, but let's add it to the subscriptions. So this is going to get added to the subscriber at the top. And now here, when we read the value, right, this is the beautiful part. We can say if subscriber, we're going to add it to the subscriptions. Subscriptions, add subscriber, boom. And now the only remaining thing to do is to run all of those subscriptions, right? So now you can see here, since we invoked count.value, we're going to add a subscription, but now here in our event listener, we're actually reassigning the value. So now this part kicks in, right? How beautiful is this, friend? So now we just need to run the subscriptions. Alright, so now we can go subscriptions, and then we're going to say for each function, and then we're going to invoke the function. And of course, we need to import effects from here. Let me just save everything, refresh. Let me see, 1, 2, 3, 4. How beautiful is this, friends? And let's of course add another effect. So here we have this effect. But let's say, for example, we want to update the HTML each time the value updates. Well, easy peasy lemon squeezy, friends. We can just say button inner text is going to be count value. And now we're going to add another effect. So now when we save it and go back to our example, 1, 2, 3, 4. And also creating a derived signal isn't really that hard either. So we can go back here to our code, and now we can just say export function derived. We're going to pass in a function, and that's basically it. Alright, so to create a derived signal, we need to create a signal, and then we're going to wrap it inside of effect, and then we're going to return the signal, and that's basically it. So I'm going to say const derived is going to be a signal, and then again we can just use an effect. And let's update derived.value is going to equal the result of the function, and then we just need to return the derived signal. Just save this. We can go back here to our code. We can say let double, and of course let's not forget to import it. Say let double derived. We can pass in a function here. We can say count.value times 2. And now instead of saying count.value here, we can just say double.value because it's just a signal, right? And if I save this and refresh, we're going to see 2, 4, 6, 8, 10, and so on. And of course, you can do other things inside of an effect. We can say, for example, if count.value is higher than 10, then we're going to console log dangerously high, and then let's just reset the value. Now we're going to see dangerously high is going to reset to 0. So actually we can even just say count value, and we can add as many effects as we want. So you can go here. Let's just say that you're going to log double. Boom, just like that. So we're going to see once you go over 10, we're going to say dangerously high. Oh, and of course, this isn't button inner text. We just want to console log double.value. Now when we refresh, you're going to see everything works as expected. As you can see, this is the main difference between the observer pattern and signals, because signals, once you set things up, you don't have to think about it anymore. Signals may look like magic, but they're relatively simple. Alright, so that's it. If you like what you're seeing, don't forget to like and subscribe, and you can also support me by becoming a patron. Thank you for watching, and catch you in the next one. Peace!